In this example on algebraic division, we're taking a look at the factor theorem. And we've got two parts of this example. Part A, we just want to show that x minus 2 is a factor of f of x. And then for part B, we're given the polynomial here, g of x, and we're told the roots, and we're asked to factorise g of x completely. So to start with here, let's take a look at part A. So for part A here, we're asked to show that x minus 2 is a factor of f of x. So if x minus 2 is a factor, what that means is that f of 2 must be equal to 0, okay? And that's true if x minus 2 is a factor. So if we just substitute 2 into our polynomial here, f of x, then what we should find is that this expression simplifies to 0. So let's take that step first. So f of 2 here, well, that's going to be equal to x cubed, where x is 2. So this is 2 cubed plus 5x squared, and again x, we're replacing that with 2 now. So this is 5 lots of 2 squared minus 19 times 2, so minus 19 lots of 2. And finally we've got this plus 10 here. So what we need to do here is evaluate this. Well, this gives us 8. This gives us, so that's 2 squared, which is 4, times by 5 gives us 20. Minus 19 times 2 gives us minus 38. And finally we've got this plus 10 here. And if we evaluate this, well, 8 plus 20 is 28, plus another 10 is 38, and 38 minus 38 simplifies to give us 0 there. Okay? So therefore f of 2 is equal to 0, and therefore what this means is that x minus 2 is a factor of f of x. So therefore x minus 2 is a factor of f of x. Okay, so that's part A done there. For part B then, what we're told is that the polynomial g of x, which is a cubic polynomial, has roots at x equals 4, x equals 5, and x equals minus 1. And we're asked to factorise g of x completely. And this is actually quite a straightforward example here. Because we've been given all the roots already, we can now go on to factorise this completely in a nice, straightforward manner. First, let's just note down the roots. So it has roots at x equals 4, x equals 5, and x equals minus 1. So the roots are x equals 4, x equals 5, and finally x equals minus 1. Now here, if a is a root of g of x, so let's just write this down. So if a is a root of g of x, okay, so if a is a root of g of x, then what that means is that g of a is equal to 0, and if g of a is equal to 0, that means x minus a is a factor, so therefore x minus a is a factor. Okay, and this is important because what it actually tells us here is that this is actually rather straightforward, because all we need to consider is the roots here. So x equals 4. Well, if x equals 4 is a root, what that means is that x minus 4 is a factor. And all we need here are the 3 factors. Once we've got the 3 factors, we can just put them together and we've factorised g of x completely there. So in that case, this simply gives us x minus 4 as our factor. Doing the same here with x equals 5. In this case, this gives us x minus 5 as our factor. And finally, repeating this one more time here with x equals minus 1. In this case, this is going to be x plus 1. So therefore, if we factorise g of x here, we can just write this as the product of its 3 factors. And simply, g of x is going to be equal to x minus 4 times x minus 5 times by x plus 1 there. And that's g of x factorised completely. And that gives us the solution there to our example on the factor theorem.